So our today discussions will base on motion. So when we're talking about motion, motion is the changing of position with respect to time. There are some things that we need to talk about in this motion. Just follow so that you can enjoy this topic. So for example, let's say we have a car. A car moves from point X to point Y. You can see clearly from here, the object covers some distance. At the same time, it takes time before it reaches X, from X to Y. That's what we mean by motion. When the object changes its position from one point to another with respect to time is what we call motion. Even in this case, we have different types of motions. We have random motion, we have translational motions, we have rotational motion, circular motion as well. So there are many like that. But there are some terms that made up these motions. We call them distance, displacement. They include all this: speed, velocity, and acceleration. Those are the terms. This point. Yeah. Those are the terms. Acceleration. Those are the terms that made up motion. Yeah. Yeah. So those are the terms that made up motion. So I will explain them one after the other. And if you check our previous video, we talk about the scalar quantity and vector quantity. Please, in case you missed the previous video, just check on what we discussed about the scalar quantities and vector quantity. We said a scalar quantity are those quantities that has only magnitude but no directions. If an object have a magnitude, that is, if it covers some distance without a particular directions, we call it scalar. And we mentioned vector too as well. We said the vector quantities are those quantities that have both magnitude and direction. That's the only difference between all the terms that we mentioned here. Like distance and displacement, let's take a look at when we talk about distance and displacement, the two terms are the same. It's just that one is a scalar, at the same time, one is a vector. Like distance is a scalar, and displacement too is a vector. That's the only difference between them. The two are the same, literally meaning, but it's just that one is a scalar, at the same time, the other one is a vector. That is the position covered by an object without a specific directions is what we call a scalar. If it moves in a specific directions, that one is what we call displacement. The same thing also similar to the speed and velocity. That one is even, if I could recall, just like secondary school work, like SS1, we know when we're talking about the speed is the rate of distance move in unspecified direction. That is, speed is equal to distance over time. That is, when an object moves from one point to another without a specific directions, you understand, just like a scalar. So the speed is the rate of distance move in unspecified unspecified direction. So we call it a distance. So in some materials, in some textbook, we can use x as distance. So please don't forget that it's not speed here. Whenever you see x simply means the distance. Whenever we see t simply means time. Please, you have to take note of these two terms. Whenever we see the distance is always represented by x. Even in some textbook, they use x. You understand? So they can use either this first one or the second one. Anyone they use between the two is still they are still referring to the same thing. So for the speed is a distance over time. Then at the same time, if you look at velocity as well, velocity is just like the rate of a distance move in a specific direction. So meaning the only difference between the speed and velocity is also similar. That is, the two are the same, but just like the speed is a scalar, at the same time, the velocity is a vector. I hope you are following right. I mentioned that for the distance and displacement, the only difference between them is that the distance is a scalar, at the same time, the displacement is a vector. So the same thing is also applicable to when we have speed and velocity. For the speed is a scalar, then at the same time, the velocity is a vector. So from here, we can say velocity is equal to displacement over time. The rate of a distance move in a specific direction is what we call velocity. So as I mentioned earlier, in physics, we use s or x to denote the displacement or distance. That way here too, I can say either x over t, or I can have change in x over t. It depends on the problem we are solving. If we are given two distance, let's say in a problem, let's say we have a two distance, for example. So you can see this symbol, we call it a change or delta. So if I have a two distance, I can make use of this. Maybe let's say in a problem we have two distance. I can say here we are going to have x2 minus x1 divided by t2 minus t1. It depends on the problem we are solving. We are coming to that. I will solve many examples so that I can be able to know how to make use of this, how to understand all the time that we mentioned here. Now, go back to the one that we mentioned as accelerations. Is the change in velocity with respect to time. Change in velocity of an object from one point to another with respect to time is what we call accelerations, meaning you can say the acceleration is equal to change in velocity, I put it here, change in velocity over time taken. So in physics, we have two velocity. Normally on the norms, we have two velocity. We have what we call initial velocity. At the same time, we have what we call the final velocity. So each of them have their own specific symbol. So whenever I see u, it simply means initial velocity. So whenever we have v is called the final velocity. So from the definition, they said acceleration is a change in velocity over time taken, meaning here we can have change in a v, something we use, over, or we can say change in a v minus u, or let's put it in a normal way, that is a v minus u over t, meaning the final velocity minus initial velocity over time taken. So please, you have to take note of this symbol. Whenever we see u, u simply means initial velocity. At the same time, whenever we see v, the v simply means the final velocity. So another problem that students encounter here is the unit. So please, in case if you missed the previous video on unit measurement and dimension, I talk about how to derive the unit in physics. We said unit is what we use to recognize a given quantity. So I've still derived them so that I can be able to know the difference between when we are given speed or when we are given acceleration or displacement. The unit is very, very important in physics. It's what we use to recognize a given quantity. Once you know the unit, then some values, they might not mention the time they are referring to, but once you are given the unit, then you'll be able to solve that particular problem. So let me derive them one after the other. When you are talking about distance, as I mentioned, that unit that unit measurement and that dimension analysis, I said the distance have many units. It depends on the problem we are solving. It has many units. Like for the distance, let me just break them here. So for the distance, it can be measured, even it can be measured in centimeter, it can be measured in meter or kilometer. So mostly we use either meter or kilometer, and I will tell you how to convert it, because in some problem you will be asked to leave the answer in terms of either meter per meter, in terms of meter, or in terms of kilometer. So normally, you know, if you recall, when you are in a primary school, they taught you how to measure time, right? Fine. You know, that one they'll be talking about 60 seconds, make 1 minute, right? 60 minutes, make 1 hour. So we also have that one. It's not only for time, we also have that conversion for distance as well. So on the note, we have 1,000 meter make 1 kilometer. That is, if you are solving a problem, maybe the value is in meter and you have to convert the answers in terms of kilometer, you can make use of this approach. 1,000 meter makes 1 kilometer. Let's say, for example, let's say we want to convert 2 kilometer to meter, for example. So I know that 1,000 meter make 1 kilometer. So x meter now will make 2 kilometers. So just like we cross multiply, that is the number that we have here, we multiply this, the one we have here, we multiply here. So if I cross multiply here, we have x times 1 is equal to 1,000 times 2. So that means that we have x is equal to 1,000 times 2. Of course, we are going to have 2,000. So meaning 2,000 meter makes 2 kilometers. But instead of you wasting your time doing all these ones, if you have to convert a value from kilometer to meter, just take the value and multiply it by 1,000. For example, I want to convert 5 kilometer to meter. Instead of using this approach, I'll just say 5 multiplied by 1,000. You understand? So 5 times 1,000, of course, you are going to have 5,000. So now, assuming the value is in meter already, and I want to leave the value in terms of kilometer, what did I need to do? Yeah, that means you are following. That means I'll just divide the value by 1,000. From kilometer to meter is multiplied by 1,000. Then from meter now to kilometer, then I'll just divide the value by 1,000. For example, let's say I want to convert 5,000 meter to kilometer. So what did I need to do here? I'll just say 5,000 divided by 1,000. So here I will have 5 kilometers. So those are the things that we need to measure in this case. So for the distance, it can be given in form of either even centimeter as well. In physics, 100 centimeter, or in general, 100 centimeter makes 1 meter. So that one too, but most of the problem under these motions, we can have a distance either in terms of meter or in terms of kilometer. So at the same time, also applicable to that of displacement, as I mentioned earlier, the only difference between the distance and the displacement is that one is a scalar quantity, at the same time the other one is a vector quantity. So go back to the speed that we mentioned here. And for the time, time is common, you can have a time either seconds, either minutes, or we can have it as hour. If you recall the one they taught you in secondary school, we know that even in primary school as well, even when we are in kindergarten, they make mention that 60 seconds make what? Yeah, make 1 hour. And at the same time, 60 minutes makes 1 hour. So even in some problems, we have the time in form of hours, and we have to convert the value to maybe seconds. So we are coming to that. So for the speed, we said speed is equal to distance over time. Distance over time. So I only want to break down the unit. So assuming the value is let's say the value of the distance is in meter and the time is in seconds. So how will I derive that one? Even if you missed that video, I talk about the physical quantities that is divided into two parts, that we have fundamental quantities and derived quantities. That fundamental quantities are those quantities that provide the standard unit of measurement that they can be changed, especially for the mass, time, and length. And we make mention of dimension, the derived two, that is made up of two or more fundamental as well. So from here, let's say the distance is in meter and the time is in seconds. So how will I go about that? I want to derive the unit for this. It's going to be meter divided by time is seconds. So that means here, this one is the same thing as a meter per second. So some material, they can leave it like this, or they can use indices. This is nothing but meter per second. It's still the same thing. I hope you are following, right? Yeah, nice. So let's say the value of the distance is not in meter and the time is not in seconds as well. Let's say the distance is in kilometer now and the time is hour. So we're still going to follow the same process. So that means if I want to do this, I can have this one to be kilometer, then time is an hour. This is nothing but a kilometer per hour, or I can put it in this form. So anyhow, we put it, either the first one or the second one is still the same. So now, for the accelerations, from the definition that we put for acceleration, we said acceleration is equal to change in velocity over time. That's what we mentioned earlier. So now we derive, since the distance and since the speed is either meter per second or kilometer per hour, so the same thing also applicable to velocity. Just like the velocity and the speed are the same, but the only difference between them is that one is a scalar and the other one is a vector. So if you go back to this, we say acceleration is equal to change in velocity over time. So let's say we firstly use the first one that we derive. The first one we derive is what? Yeah, we derive meter per seconds. So the time too is also seconds. Now, if you look at this one now, how many seconds do we have now? 2, right? Yeah, fine. So that means here I can have meter per seconds multiplied by seconds. Of course, we are going to have seconds squared. So it's a material they can leave the result like this, meter per second square, or they can leave it like this. Anyhow they use is still the same. So now, so let's say the value is in kilometer per hour, as we mentioned earlier. So if I go here, kilometer per hour, time 2 is also hour. So now we have 2 hours now. So here I can have kilometer per hour square. So it depends on the problem we are solving. Can leave it like this. So please take note of that. The reason why I want to break down the units is that mostly students used to find it difficult to recognize the quantities and the conversion of units from one to other. That's why I firstly break it down. So that's why we have the how to convert the unit from one to the other. This is made easy academia. We are trying to break down the problem so that it will be able for you to be able to tackle it either exam, maybe either objective text or theory text. So now let's go further. We talk about for the distance, for the displacement, for the speed, for the velocity, at the same time for the acceleration, derive their formulas one after the other. So now let's take a look at one or two problems, then we go further. So the first one we said that speed, or we have velocity. Please note the two have the same formula because they are the same. It's just that one is a scalar and the other one is what? A vector. So that is a distance over time for the speed, distance over time. Then for this, we have displacement over time. Then for the acceleration, we said acceleration is change in velocity over time. Even there's another one we call it retardation. Retardation is just like when the object is decelerating. That is the opposite of acceleration. We are coming to that as well. So change in velocity, change in velocity all over time. Or we can have it like this mathematically. That is final velocity minus initial velocity over time. So those are the formulas that we need in this area before we move further. So let's take a look at maybe one or two examples, then we go out to, even there's another one we call it instantaneous velocity. We are coming to that as well. So let's take a look at one or two problems. Let's take a look at this. Let's bring one question. They said a man takes 4 hours to travel a distance of 180 kilometers. What is his average speed? What is his average speed? So let me add another one. Maybe like I said, leave your answer or leave your result in meter per seconds. Leave your result in the first one, kilometer per hour. Then the second one in meter per seconds. So let's see. Let's see how we are going to approach this problem. It's one question, and we are asked to leave the result in terms of kilometer per hour, at the same time in terms of meter per seconds as well. Now let's look at the problem. They said a man takes 4 hours. You can see in the first data given, they didn't mention either is it time or is it distance or is it speed or whatsoever. But I told you the unit is very, very important. The unit that we have, that value will determine is it going to be a distance or a time or velocity. We can see when we have hours, what are they referring to? Yeah, fine, that is time. So that means let's try that given data first. We are given time. The time is 4 hours to travel a distance of 180 kilometers. So luckily for us, the dimension is this. Even without being mentioned, we know when we have kilometer is for distance. Good. So the distance we have here is 180 kilometers. So now they now said what is his average speed? Normally we know that the speed, what is the formula for speed that we derived earlier? Speed is equal to what? Yeah, speed is equal to distance all over time. So from the data given, we have our distance. So what do we have for distance? We have distance to be 180 kilometer divided by, we have the time to be 4 hours. Fine. So 4 hours. So how many 4 can we get in 180? We are going to have 45. Then we are going to have kilometer per hour. So that's the first requirement. It's able to leave the result in terms of kilometer per hour. So the second one there says we should leave our answer in terms of meter per second. If you like, you can go with the result you got here, or if you like, you can go back to the problem and convert the result one after the other. Anyhow you use it, either you take the result you got and convert it to meter per seconds, or you start from the problem itself by converting the hours to seconds, then convert the kilometer to seconds to meter. Is still the same thing. Either you use the first approach or the second approach. The two methods are the same. So since we have gotten the result in kilometer per hour, we can easily convert this one to meter per seconds. I hope you are following, right? So now let's take a look at the value. We have 45. I've already told you that 1000 meter makes, yeah, good, 1 meter. That means that we have 1000 divided by, this is hours. How many seconds make 1 hour? Is it going to be 60 plus 60? Yeah, it's going to be 60 times 60. Yeah, good. And 60 times 60, we are going to have 3600 seconds. Meaning in physics or in general, 60 seconds makes 1 minute, then 3600 seconds make 1 hour. So now, if you multiply this, 45 times 1000, we are going to have 45,000 divided by 3600. So if you press your calculator to check the result of this, definitely we are going to have a 12.5 meter per second. So meaning if the value is in kilometer per hour as required, it's going to be 45 kilometer per hour. And if you ask to leave the result in meter per seconds, it's going to be 12.5 meter per seconds. So let's take a look at another problem. Take a look at another problem. Now you see how we are going to make use of the approach. Let's look at this one. A question from JAMP. They said a man takes 2 hours to drive. Let's use that one, to drive to a distant city 80 kilometer north Nigerian. So we Nigerian. What is his average? What is his average velocity in meter per second? So now in this problem, they specify the unit or why we are going to leave our results. Here it's not in kilometer per hour. The problem says we should leave our answer in terms of meter per second. That means I need to convert the hours to seconds. At the same time, I will convert the kilometer to meter. So now let's write down the data that we have from the problem. A man takes 2 hours. That's our what? Yeah, good. So our time, we are given time to be 2 hours. Then to drive to distant city, 80 kilometer, as we know that when we have kilometer is for distance. Good. So we are given distance to as well to be now. So I told you either distance or displacement, we are still referring to the same thing. So here we are given the value to be 80 kilometer per hour. But now the value of the distance to or displacement to is in terms of kilometer, meaning we have to convert it to, good. So, and we mentioned that 1000 meter makes 1 kilometer. So now I just have to have 80 multiplied by 1,000. So here I will have 8,000 meters. So now you can see. So let's convert the time to, since the value is in hours, I can have the time to be 2 multiplied by, 1 hour, 3,600 seconds make 1 hour. We have explained that earlier. So now, instead of having this, I can have 2 multiplied by 3,600. So if I do that, so the time we are going to have 7,200 seconds. So now, the time is 7,200 seconds now, and our distance is 8,000 meters. So, recall from the formula for velocity as required, we know velocity is displacement over time. Displacement over time. So displacement now, we have the value to be 8,000. This is 8,000 meter. And our time, after we converted the value, we have it to be what? 7,200. So if you define this to calculators, I think we are going to have, you check your calculator to have this result, we are going to have 11.11 meter per second. So you can see, so the value of this, they have to leave the result in form of meter per second. But assuming they did not ask us to leave the value in form of meter per second, that in terms of kilometer per hour, then we use 2 hours. At the same time, we use 80 kilometers. So let's take a look at another problem. Let's see another problem from here. Let's see, the question say that a car moving with a velocity of 5 meters per second at a point, let's say at a point A, accelerate uniformly, straight line, accelerate uniformly, and when it reach point B, point B, its speed or its velocity, let's use that, its velocity becomes 15 meters per second. If the time taken to travel from A to B is 10 seconds, what is the car's acceleration? What is the car's acceleration? So let's look at this problem as well. It's another problem. So they said a car moving with a velocity of, recall from the definition of acceleration, that acceleration is nothing but change in velocity over time. So that means if I want to find the velocity, I need like 3 values there. I need the final velocity, at the same time, initial velocity, then the time taken by the object to travel from one point to another. So now, a car moving with a velocity of 5 meters per second. How will I go about that? That's the first velocity, which is initial velocity. So we are given u. We are given u to be 5 meters per second. At a point A, accelerate uniformly, and when it reaches another point B, its velocity becomes 15 meters per second. So my v is 15. I told you earlier, when we have u, is nothing but initial velocity, and when we have v, is our final velocity. So if the time taken to travel from A to B is 10 seconds, when we have seconds, what are they referring to? Yeah, time. Good. So our time is 10 seconds. They now say we should find the acceleration of the car. So now, from the formula we have for acceleration, we said acceleration is equal to change in velocity over time taken. So that one we are going to have A equal to our V that we have from the problem is what? 15. And we have 15 minus our U that we have is also what? 5. Nice. Then divided by the time given from the data is what? Yeah, 10. Good. So here we have A equal to 15 minus 10, 15 minus 5, we are going to have 10 all over 10. So throwing 10, you are going to have 1 meter per second square. You can see the result here we have for A is 1 meter per second square. Even there's another one that we call it instantaneous accelerations. That one too is nothing but just like a change of displacement at a given instant, or as the time limit of a value of displacement has given, maybe to be 0. Let me talk about that one too and solve one problem. That we'll call instantaneous velocity. Even there are some that require for you to maybe to find a derivative. Instantaneous velocity. Instantaneous velocity. That one is given as this: V is equal to limit of maybe change in time to be 0 for delta x over delta t, which is the same thing as the x dt. So in this case, mostly if you want to get the value of this, it involves derivative, how to differentiate it. Then we are coming to that. So let's see a question from there. Let's see. Let me just bring one question. Maybe they said if the motion of a football player on a pitch is described as x equal to a plus bt squared a meter. First question now says find the displacement. Find the displacement in time interval 2 seconds and 5 seconds. Find the average velocity. Find the average velocity. Now we got 3. Find the instantaneous velocity at 2 seconds. So let's see a problem. You can see this in this case is not like the one we solved in the first one and the second one. This one is constructed in terms of equations, just like a formula, but it's also simple and straightforward. You know, I told you when they have x is nothing but displacement, or they can use s. We are coming to that as well. They say if the motion of a football player on a pitch is described as x is equal to a plus bt squared in meter. The distance is measured in meter. They now said find the displacement in time interval 2 seconds and 5 seconds. The second question they said find the average velocity. Then find the instantaneous velocity at where? At 2 seconds. So it's nothing. You just have to calculate this one. It's also simple and straightforward. You don't need to worry about that. So let me solve them one after the other. Stars, please check. Can they see from here? Okay. So let's take a look at the problem. The question says if the motion of a football player on a pitch is described as x is equal to a plus bt square in meter. You see this m they use here is nothing but meter. And then I told you that the distance is measured in meter. So we are given x to be a plus bt square. You see here, the A that and B that we have here, they're just constants, and the time we have here is for time. Now, find the displacement, meaning I was asked to find the value of x in time interval 2 seconds and 5 seconds, meaning when the time is 2 seconds at the same time when the time is 5 seconds. So now let's look at that. Let's first find the first one for t to be 2 seconds, meaning we are using the first time now. You know, the first time given to us from the problem is what? Is 2, right? So it means that in this equation, whenever I see t, I will put my t to be 2. So that we have x equal to a plus b. So my time is 2 now. So that means that we have 2 squared. I hope you are following, right? Nice. So that means here we have this one to be a plus, when we have 2 squared, it simply means 2 times 2, and 2 squared we are going to have 4. So here we have a plus 4b in meter. If you are following, right? So the second one, they said when the time is 5 seconds. So how are we going to go about that? For t to be 5 seconds. So meaning in that equation, whenever I see t, the value of my t should be what? Should be 5. So let's go back to that problem. So that means that we have x is equal to a plus b. So instead of writing t now, our time is 5. That means that we have 5 squared. So here we are going to have this one to be a plus 5 squared. 5 squared simply means 25. So this one is nothing but a plus 25b. So here my second x now is a plus 25b in meter. So this is the first one, and this is the second one. I hope you are getting it right. You can see it's also simple. It's nothing difficult compared to the first one as well. So now our distance for the first one, we have it to be a plus 4b meter. The second distance we have is a plus 25b meter. So let's calculate that distance now. Changing distance now. Can I just clean this side? So now, I can have changing x is equal to x2 minus x1. So the first x, the x2 that we have is a plus 25b minus, you see, our x1, we have the value to be a plus 4b. So now, if I open the bracket of this, I can have this one to be a plus 25b minus times a, and we have minus a, minus times 4b, we are going to have minus 4b. So now a minus a, that is 0, fine. So 25b minus 4b, we are going to have 21b in meter. So that's our total what? Our total distance. I hope you are following, right? You can see it's also simple. It's just like they're just trying to package the equation. So either they package it or not. Since you have us made easy academia, you don't need to worry about how they bring equation of the motion or related to anything motion. So now, let's go back to the second problem. They said we should find the average velocity. Average velocity. So how are we going to go about that? Recall that when we have velocity, so let me just, okay. So the second problem, they said we should find the average velocity. So recall that we know that velocity is nothing but displacement over time, right? Okay, good. And since this one we know is in the form of a distance, so that means I can have this one to be changing x over changing t, because we are given 2 time at the same time 2 distance. So here this is nothing but x2 minus x1 over t2 minus t1. But luckily for us, we have gotten, you don't need to find this one again because we have gotten it already. That's changing x, x2 minus x1. What do we have for the value here? Yeah, good. We have 21b divided by t2 minus t1. That's 5 minus 2, because this is t2, this is t1. So t2 is 5, t1 is 2. So here I can have this one to be 21b divided by 5 minus 2. Definitely we are going to have 3, right? So how many 3 can we get in 21? We are going to have 7b, the meter per second. So meaning our average velocity is equivalent to 7 what? 7b. Because a and b that we have, they are just constant. But in the third problem, they said we should find instantaneous velocity. And I told you that one requires differentiation. It's not like the way we find average velocity. So how would we normally differentiate? Let me just take a look at it. Let's say I want to differentiate, let's say T4. So if I want to law of differentiation, the power will just come forward. Times that we have 4t, then 4 minus 1, right? So this is nothing but 4t cube. Let's say I want to differentiate 5t squared, for example. The 5 will come forward. So when it comes forward, and we have 5, and the 2 will come forward. So 5 times 2t, then 2 minus 1. So 5 times 2, and we have 10t1. So that one is equivalent to 10t. So, and the differential of constant is nothing but what? It's nothing but 0, 5. So that means for me to find the instantaneous velocity of this, I have to differentiate this function. So we are given that x is equal to a plus bt squared. So now look at the way I will differentiate it. That means that we have dx over dt, because velocity is still displacement over time. So it's not going to be dx over dA, because a and b that we have here are just constants. So differential of a, there's no t here. So differential of a is going to be 0 because you don't have any t here. Now differential of t squared, just like we keep b as a constant, as I told you, differential of t squared, 2 will come forward, is 2t, 2 minus 1, then we are going to have 2t. I hope you get it right. So this one is going to be 2t, 2 minus 1. You understand, right? So here we have, this is 0, b times 2, and we have 2b, then t. So now, they now specify that at t equal to, let me connect the equation again. He said at t equal to 2 seconds. Now, you will be given any values, but in the problem they specify that at t equal to 2 seconds, meaning in that problem, if I see my time to be 2 seconds, so here I can have this one to be 2b bracket of 2. So 2 times 2 here, we are going to have 4b meter per second. So meaning now we have the average velocity to be 7b meter per second. At the same time, we have our instantaneous velocity to be 4b meter per second. So that's the only difference between that one. So in most cases, if I want to find the instantaneous, it's used to require normal derivative. So now, after that, we have motion with constant acceleration. So that one is equation of motions. We derive like 4 formulas. So I will make use of them one after the other, so that you know how to approach how to use them to solve a particular problem. Equation of a motion. Equation of motion. So I will derive all the formulas one after the other. I will derive them one after the other. Equation of motion. Equation of motion. So we are going to derive all the formulas one after the other. Now, so we have explained the distance, displacement, speed, velocity, at the same time acceleration. So I'll be making use of them to derive equation of motions, and now we're going to use them to solve a particular problem. Now, let's start from the first one. Recall from acceleration. What do we have from acceleration? Recall from acceleration, we said acceleration is equal to v minus u over what? Over t. Remember this one, right? So a is equal to v minus u over t. So if I cross multiply here, that means that we have at equal to v minus u. You can see if a and t multiply each other, we are going to have at, then we have v minus u. So if you collect like times here, we are going to have at, this is minus. So when the minus comes to this side, we are going to have plus u equal to v. If I have b plus a in mathematics, it's nothing but a plus b. So if I have at plus u, I can still write it as a u plus at. So this is the first formula for equation of motion. That is the v equal to u plus at. This is our equation what? Equation 1. So that means the problem, maybe I was asked to find a particular function, and I see that maybe if it relates to the velocity, the initial velocity, the acceleration and time, I can make use of this, the first formula here. So another one we derive, let it come from average velocity. if I want to write the average velocity, which is u plus v over 2, I told you earlier, when we have u is nothing but initial velocity, when we have v is our final velocity, and we know normally that speed is equal to distance over time. So in some materials, they use x as distance, while some use s as a distance. So if I put it here, so I can have average speed or average velocity is equal to a distance over time. So now I want to make my distance as the subject of the formula. If I cross multiply, we have 2 and x will multiply each other. At the same time, u plus v also multiply t. That means that we have 2x is equal to u plus v of t. So now I want to make my s as the subject divided by 2. So if this cancel this, we have x is equal to u plus v over 2 of t. So I will make use of this formula as well to derive another equation of motion. So now what we have now is that x is equal to u plus v over 2 of t. So now, Ustaz, please, can you help me to check if I write here? Can they see from here? Yeah. They can see that. Okay, fine. So now go back to what I derived here. We said x equal to u plus v over t over 2 now. So now from the equation 1, we have that our v is nothing but u plus at. So let's substitute it here. And we have x equal to u plus, so instead of writing v now, I will write v to be u plus at. So we have u plus at all over 2 of t. You can see we use one equation to derive the other one. So now if I add this one together, u plus u, we are going to have 2u plus at of t all divided by 2. So what is the next step now? Can you get the next step? Yeah, we are going to open the bracket. So here we are going to have x equal to 2 times t, we are going to have 2ut, at multiplied by t, we are going to have at squared all divided by 2. You can see this 2 is just a fraction for the first one at the same time for the second one, meaning it will affect the first one at the same time it will affect the second one. So here we have x equal to 2ut over 2 for the first one plus at squared all over 2 for the second one, just like we split these 2 for the first one as well for the second one. So that means here we have x is equal, if 2 cancel 2 here, we have ut plus, this one is just like a fractions, I can have it as 1 over 2 at squared. So this is for the second equation. You can see the derivation is just so simple. You don't need to worry about anything here since you have also. Now you can see what we have for this one is that x is equal to ut plus 1 over 2 at squared. So this is our second formula for equation of motion. So the first one we derive is v is equal to u plus at. The second one we have is ut plus 1 over 2 at squared. And we have explained what each term represented. We know when we have s is nothing but distance. When we have u is initial velocity. When we have t is final velocity. And when we have a is called what? Yeah, acceleration. So now we derive 2. Let's take a look at another one. Let's derive the third one too as well. Let's derive another one. So can I just clean it? Let's just clean it so I will write them later after the derivation. So now we want to derive another one. From here we say that x is equal to u plus v over 2 of t. So from accelerations, I can find the value of my t. We have a is equal to v minus u over t. So now I want to make my time as the subject of the formula. The moment I come multiply, that means that we have at equal to v minus u. So making the t as the subject divided by a divided by a. So if this cancel this, we have t equal to v minus u all over a, right? Yeah, fine. So that means in this equation now, instead of writing t, I will put my t to be v minus u over a. So here we have x equal to u plus v over 2. So this is t now. Instead of writing t to be t now, we use our t to be v minus u over a. I hope you are following, right? Fine. So now the next step is simple expansions. That is expanding the time. This one we multiply this one too as well, then the other one too. So here we have x equal to u times v, and we have uv. I want to expand now. That is, I'll firstly use the first one here to multiply these two here. So u times v, you have uv, u times minus u. Of course, we are going to have u squared. V times v, we are going to have v squared. V times minus u, we are going to have minus uv. So now, denominator 2, we also multiply denominator. So 2 times a, we are going to have 2a. You can see, just make a simple expansion. So here we have x equal to uv minus uv. That's going to be 0. So what we have left now is a minus u squared plus a v squared all over 2a. So can you get the next step here? Yeah, fine. We cross multiply, meaning x and 2a will multiply each other. So we have x times 2a equal to minus u squared plus v squared. So s times 2a, definitely we are going to have 2ax equal to minus u squared plus v squared. What's going to be the next step here? We want to make our v, which is final velocity, as the subject of the formula. If I collect the like terms, this one is negative. So when the negative comes here, it's going to become positive. So here we have 2ax plus u squared is equal to v squared. We just collect the like terms here because this is minus. So when the minus comes here, it's going to become plus. So here we have v squared equal to, as I told you earlier, if I have b plus a is nothing but a plus b. So if you have 2ax plus u squared now, you can see write it as a u squared plus 2as. So this one is known as equation 3. This is the third formula for equation of motion. You can see the derivation is also simple too as well. In some exam or in some situation, you will be asked to derive all the 3 equations for motion, either in equation 1 or equation 2 or the third one or the fourth one. Just follow the same process, then you can be able to derive them one after the other. So let's write them out now. The first one we have, let's write them out and see how we can make use of them one after the other. The first one we have is so the first one we derive, we say v equal to u plus at. This is equation 1. Now the second one we derive, we have x is equal to ut plus 1 over 2 at squared. This is equation 2. And the other one is v squared equal to u squared plus 2as. This is equation 3. These are the 3 that we derive. But you see, there's another thing that we have to take note of in these situations, because our, what do we call it? A and G are equal in some situation. G, if it means the first fluid that we did in this case, we talk about acceleration due to gravity. We said G is nothing but acceleration due to gravity. Acceleration due to gravity, which is the same thing as A in physics. They are the same, if you recall in substitution, you have to use either 10 meters per second squared, or you can be asked to use 9.8 meters per second squared. So you see, in any problem you are solving, if they said the object moves vertically upward, at that point your G will be negative. And if the G is negative, it will affect the value of the final velocity to be 0. Or if they say an object comes from rest, please go in the materials. I will include all those conditions so that you'll be able to use how to approach the problem. If they say an object comes from rest, meaning at that point your U is going to be 0, which is initial velocity. And if the initial velocity is 0, mostly our G is going to be positive. Now, that means in this formula I can rederive them that I can have that one to be V is equal to U plus GT now. It's A, since A is equal to G. So if the object moves vertically upwards, so if the G is negative, that means I can have, for G to be negative, you can have this one to be U minus GT now. You understand? Because If plus and minus multiply each other, it's going to become minus. Even in second conditions, that we have x is equal to ut plus, we can have it as 1 over 2 gt squared. And for the case, for this one to be negative now, and we have x is equal to ut minus 1 over 2 gt squared. And for the third one as well, like I have v squared is equal to u squared minus 2al. Those are the conditions that we need to follow in some problems. You just have to follow the three conditions. If they said an object comes from rest, if an object comes from rest, mostly our u is going to be 0. And if the value of u is equal to the 0, then at that point it means our g or a is going to be positive. But in some situation, if you are given the object to be moving vertically upward, at that point it means your g is going to be negative.